Welcome, Chapter 5, Section 1, Practice Problems. So we're going to go over a couple of these here. Angles in standard position. So these are good to use to do for practice, because remember, this is 0 degrees, this is 90 degrees, this is 180, this is 270, and 0 degrees is also 360 degrees because it's a full circle. Remember, everything comes right back to where we started. So 30 degrees. That one would be in quadrant 1. 300 degrees, of course, would be somewhere in this quadrant. Negative 80 degrees. I want to focus on that one. So positive angles go clockwise, so counterclockwise. So they go this way. Negative angles go clockwise. Clockwise. So negative angles dip down. And negative 80, so this now is negative 90 degrees. So that means that negative 80 would probably be somewhere in here. Negative 80 degrees. Now, if we're talking about radians, this is 0. This is pi over 2 radians. This is pi. This is 3 pi over 2. And this 0 is also equivalent to 2 pi. Remember, because it's a circle, we come right back to where we started. So if we were looking at 2 pi over 3, so if I wanted to break these up, and again, you have all of the angles are given in the previous video. So pi over 3 means that there are 3 of them per every half circle. So here's a pi over 3. So you're dividing 180 degrees into 3 parts. So that's 60 degrees each. And that gives this as 2 pi over 3. Okay. So arc length is S. Area of a sector will always be A. So our S is equal to R theta. And remember, theta has to be in radians. So this is going to be, the radius is 3, and we need 140 degrees. But we need that in radians. So I can just multiply this whole thing by pi over 180. So that gives me, these will cancel. That gives me 3 times 14 pi over 18. I can get rid of a 3 because 18 is 6 times 3. So that gives me 6. I can get rid of a 2, which will give me 7 pi over 3 as my arc length. So that means that red area is 7 pi over 3, this red line. That's how long that is 7 pi over 3. Now, if I wanted to find the area of the sector, it is half theta r squared, which is equivalent to half the arc length, which is S, times r. So since I have S, which is 7 pi over 3, I can just take half 7 pi over 3 times 3. These 3's will cancel. This is that formula. And we will get 7 pi over 2 as the area. And the same can be done here. So converting radians to degrees, remember we multiply by 180 degrees over pi. So if I wanted to take 11 pi over 6 and convert it to degrees, I would take 180 degrees divided by pi. These pi's would cancel. I would get 11 times 180 degrees divided by 6. Well, 6 times 30 is 180. So I can reduce that. 11 times 30 degrees, and then you can use your calculator, whatever that would be in degrees. If you have negatives, you keep it negative, because negative angles, whether they're in radians or degrees, will stay negative angles. And if I wanted to move it from degrees to radians, I would multiply by pi over 180. So let's take number 39. We've got 150 degrees. I multiply by pi over 180. Remember, those degree symbols cancel out, and we get 150 pi over 180. I can cancel out a 10, so I can get rid of the zeros. 15, if I break that down, that's 5 times 3 times pi. 18 is 6 times 3. These will cancel. So we will get 5 pi over 6, and that is the same thing as 150 degrees. Okay, so we're going to look at some of these. Find the length of the arc of a circle of diameter 14 meters subtended by the central angle of 5 pi over 6. That means that our angle is 5 pi over 6. So what we have, and we need the length of the arc. We need arc length, which is S equals R theta. Remember, theta is in radians. It's always in radians. The diameter. Now, what is the diameter? Because that doesn't sound like the radius that we need. Well, the diameter is 2 times the radius. So that means that we would just cut our diameter in half, and that would be our radius, because the diameter is all the way across, and the radius is only half that. So that gives us 7. Our central angle is already in radians. So we get 5 pi over 6, and you would just multiply those out, and that would be your arc length. Where is, let's try this one, 43. So now it wants the arc length for a circle that has a radius of 10. Remember, it's S equals R theta. So the radius here is already given, which is 10. The central angle is 50 degrees, but I need that in radians. So I have to multiply it by pi over 180. So that gives me 10 times 50 times pi divided by 18 times 10 is 180. So now I have 5 times 10 times pi over 9 times 2. Well, our 10 is 5 times 2, so these 2's can cancel out. And we will get 5, we'll get 25, because it's 5 times pi, 25 pi over 9. And this is the arc length, 25 pi over 9. Okay, you can do the same thing with the area of a sector. Remember, the area of a sector is half theta r squared. It's also half arc length times r. So we'll do 1 in degrees. Here we go, 47. So they're giving us a 30-degree angle. We need to put that in radians. So we're going to multiply that by pi over 180. These zeros and degree symbols will cancel, so we'll get 3 pi over 18. 18 is 6 times 3. So these 3's will cancel and we will get pi over 6. So that means we have half times pi over 6 times r squared, because we're using this one now. The radius is 20. So this gives us pi times 2 times 10 is 20, times 2 times 10 is 20, over 2 times 3 times 2, and that's the 2 times 6. So we're just factoring it all out because I know things are going to cancel. So that gives us 100 pi over 3. That is the area of the sector. So coterminal angles now. So we need an angle between 0 and 360 that's coterminal with this angle. Now remember that involved adding and subtracting multiples of 360 or 2 pi. So these are in degrees, which means we're going to use degrees. So 700. I'm going to keep subtracting 360 until I get an angle smaller than 360. Okay. Oh, 340. That is smaller than 360. So this would be our coterminal angle, 340 degrees. So let's try a -1. This is number 51. So we have -110. We're just going to keep adding 360. And that's how we would use this one. So for here, negative pi over 9, we would add 2 pi. But you're going to have to find a common denominator. So it's going to be the same as pi, negative pi over 9 plus 18 pi over 9. 10 pi over 3, that's greater than 2 pi. So we'll have to subtract 2 pi to give us something. 57 and 56, those would also involve subtracting 2 pi. Don't worry about any of these problems. We're not going to practice them. So yeah, that was 5.1 problems, and thank you. I look forward to seeing you in the next one.